All right, so we're going to work through an example of a double angle identity or formula and how it can be used to find exact values. So what we're given here is that the cosine of some angle is equal to -3/5. We're also told that that angle lies in the third quadrant. That's what this stuff right here says, right? Pi and 3 pi over 2 defines the third quadrant. What that does is it allows us to draw this triangle, right? And it's an arbitrary value for theta, but we know it's 3/5, right? So the ratio of the adjacent side of a triangle to the hypotenuse should be -3:5. And so, again, this is an arbitrary angle, theta. Just the fact that it's between pi and 3 pi over 2, pi, 3 pi over 2. So the reason I'm drawing that, that allows me to label this triangle as -3 and 5, right? Because that little reference theta in here would have a ratio of -3/5. You can use Pythagorean theorem to find the vertical value of this triangle. Most of you already know that it's a 3, 4, 5. It's a Pythagorean triplet. The only piece that should be labeled differently than what I just wrote here, because it's down, it's underneath the x-axis. That should be a -4. And I always start these problems by labeling my triangle so that all the other stuff that happens after it flows very cleanly. So I know that my sine double angle is actually equal to, let's see, sine of 2 theta is equal to 2 times the sine of theta times cosine of theta. Well, here's the thing. I know already that the cosine of theta is the same as -3/5. That means we can substitute cosine of theta with -3/5 at any point in this problem. So we're taking this and we're putting -3/5, right? So my sine of 2 theta is equal to, well, we've got 2, and the only other piece of information we need to label and write down and kind of copy over is this one right here, sine of theta. But if I have theta here and I know the cosine is -3/5, sine would be opposite over hypotenuse, right? It's the vertical value over the hypotenuse. And that means the sine of theta is equal to -4/5. So if I'm going to simplify this one and finish off this problem, I have that the sine of 2 theta is equal to, let's see, 2 times -4 times -3 is 24. And of course, you can kind of think of that as 2 over 1. 1 times 5 is 25. And so the sine of 2 theta is 24/25 if the cosine of theta is -3/5 and theta lies in the third quadrant. So all of this information that's given is important to come up with our final answer right here of sine of 2 theta being equal to 24/25.